The second thing we would like to discuss is the distance traveled by the accelerated object. You will see that the distance traveled by an accelerated object is not difficult to find. Galileo can be regarded as a father of modern science. He always wanted to verify a concept or an idea by doing the related experiments. This is a picture by Giuseppe Bezzoli, illustrates the demonstration by Galileo for the accelerated motion of an object using an inclined track. This is the inclined track used by Galileo to study the accelerated motion of an object, and he measured the traveling time using a water clock like this. You can see the detail of this experiment from this website. So he dropped an object from these points and then he measured the time by the water clock. Interestingly, Galileo found that the distance traveled by the accelerated object is proportional to the square of time. So the distance is proportional to the square of time, although he did not use a proper stopwatch. I will start our discussion by comparing two motion. The motion with constant velocity, which is the acceleration is 0, and the motion with constant acceleration, here I give the acceleration is 1 meter per second square. Here you see the distance traveled by the constant velocity motion is always the same for every second. For example, if I have a car here and it's moving with constant speed 5 meters per second, so every second the distance traveled will be 5 meters. And now the situation is different for the accelerated motion because in 1 second the speed becomes 6 and then 7 and then 8 and so on, and you see that the distance becomes larger and larger. Now you ask, how do we find the distance traveled by an accelerated object? Well, I will briefly explain to you how we can find the distance traveled by an accelerated object. Suppose here we have a car and it's moving with a constant velocity 5 meters per second. You can tell that after 1 second, the distance traveled by this car is 5 meters. And if the car is moving with constant speed 6 meters per second, and then the distance traveled after 1 second will be 6 meters. Now, let us think this situation. Imagine that the speed of the car is increasing from 5 meters per second to 6 meters per second. After 1 second, you will surely say that the distance traveled by the car is between 5 and 6. It won't be less than 5 meters or more than 6 meters. Well, because if the car travels with 5 meters per second, the distance will be 5, and that's the minimum. And if the car travels with 6 meters per second, the distance traveled will be 6 meters, and that's the maximum. Now, let us think that if the increasing speed occurs gradually, you would say, aha, this must be at the average of 5 and 6 meter, or this car must travel 5.5 meter. Keep in mind that this can happen if the speed increases gradually. Now we can find the distance of the car, which has a constant acceleration 1 meter per second square. In the first 1 second, the distance traveled here will be 5.5 meter, and then in another second, the distance traveled here will be 6.5 meter, and in another second, which the speed is increases from 7 to 8, the distance travel will be 7.5 meter, and then in another second the distance travel will be 8.5 meter. So now let's put this number here. From 0 to 1 second, the distance is 5.5, and then from 1 second to 2 seconds, the distance is 6.5, and then 7.5, and then from 3 seconds to 4 seconds, the distance is 8.5. So that you can calculate the total distance from the beginning until 4 seconds. It's 28 meters. So this is how we can obtain the distance for an accelerated object. So if this car has an initial speed 5 meters per second and it's accelerated 1 meter per second square, and you find that the final speed is 9 meters per second, then the distance traveled after 4 seconds will be 28 meters. Interestingly, if you imagine that this car moves with constant speed 5 meters per second, so if it's moved with 5 meters per second, and then after 4 seconds, so the speed is constant, the distance traveled here will be 20 meters. And secondly, if the car moves with constant speed 9 meters per second, so let me write 9 meters per second, and it moves 4 seconds, the distance traveled after 4 seconds will be 36 meters. And you see that these numbers are related, so that you can find the 28 here is 20 plus 36 divided by 2, or we can say that this is the average of the distance traveled by 5 meters per second and 9 meters per second. So if I have an object that has initial speed, let's say 10 meters per second, and it's accelerated so that the final speed will be 20 meters per second, and the time from here to here is, let's say, 4 seconds. Then you want to know the distance traveled by this car. You can find that the distance will be 10 times 4 plus 20 times 4 divided by 2. Or here you can get 40 plus 80 divided by 2. So the distance will be 60 meters. Now, if I have an object that has an initial speed, let's say 5 meters per second, and then it's accelerated 2 meters per second square, and we are asked to find the distance after it travels 4 seconds. So first, we can find the final speed. As you already learned before here, that 2 meters per second square means that every second the speed will increase 2 meters per second, meaning that after 4 seconds you will get the increasing speed 8 meters per second. So this is the delta V. And if your initial speed is 5 meters per second and then you get 8 meters per second, then your final speed will be 5 meters per second plus 8 meters per second, or you get 13 meters per second. And then the distance traveled here is 5 times 4 plus 13 times 4 divided by 2, or 20 plus 52 divided by 2, or you get 36 meters. So in general, if you have an object that has initial speed v0, and then after it moves t second, the speed becomes v, you can find that the distance traveled here is v0 times t plus v times t divided by 2. Or here, in other words, we can also, if we have an object that has initial speed v0 and it's accelerated with acceleration a, and you can find the distance after t. So you know that first the final speed v here will be v0 plus the increasing speed, or a times t. So now if we calculate the distance like v0 times t plus v times t divided by 2, and then we put v here, v0 times t plus v0 plus acceleration times t, and then you can see that finally you will get v0 times t plus 1/2 times a times t square. Of course, this is a formula for distance of an accelerated motion, but I do not recommend you to memorize this, because look, you can easily get this one. So when Galileo dropped an object on the inclined track like this, you see that this object will get an acceleration a. And if we want to find the distance traveled, we can certainly use that the distance is v0 times t plus 1/2 times a times t square. And notice that the initial speed here is 0 because he dropped it. So this is equal to 0, and we get 1/2 times a times t square. And this is what Galileo found, that the distance is proportional to the t square.